This is example 1 from the Rational Functions Part 2 lab. We have the following function. We want to determine some aspects of this function, such as if it has a horizontal asymptote, an oblique asymptote, a vertical asymptote, and if it has any holes. So this function is already completely factored in its prime factorization, and nothing cancels, so we know that there are no holes. Vertical asymptotes will be the denominator equal to 0. So here, if x is 4, then the denominator x minus 4 would be 0. So our vertical asymptote is at x equals 4. So now these two things should be a review from last week. We're going to look at horizontal asymptotes and oblique asymptotes. So this function either has one or the other depending on the degree of the top or the bottom. So we need to find out first the degree of the numerator and the degree of the denominator. Now what we mean by degree is the exponent on the x's, or the leading variable. So the leading variable here on the top from 9x minus 2 is 1. The degree of this is 1 because there's a little invisible exponent there that is 1. For example, if we had the polynomial 9x squared plus x plus 2, the leading degree of this polynomial would be 2. So we know that the degree of the numerator of this function is 1 on the top. And the degree on the denominator is the same. The highest exponent of the variable x is 1. So we have the degrees of 1 over 1. Now, there's a rule that if the degree of the top is equal to the degree of the bottom, then there is a horizontal asymptote. There is no oblique asymptote. And the way we find that horizontal asymptote is we look at the coefficients. The coefficients are the numbers in front of the leading degree. So here we have a 9 in front of the leading degree of the leading variable of 9, and there's a little invisible 1 here that's in front of this x on the bottom. And our horizontal asymptote will be these leading coefficients. So we have 9 over 1, and that's just equal to 9. So if we write that in a actual format, since this is a horizontal asymptote, we have this at y is equal to 9. So for a horizontal asymptote, we have y is equal to 9. And for oblique asymptote, we have not anything.